you know we started. Let's see here. School, math, final project, design study. All right, now if I come over here. Fluebits. Okie doke. Should we try to fix this up while we maybe wait for Jason?
Sure. Sounds good.
Okay. So according to this,
There was one thing he said, we shouldn't do mini packs or something.
yeah, just do regular bags.
Yeah.
So, okay, so if we want to ask a simpler question than a ratio, maybe we should ask, and we can do an ANOVA test on it, is just if the number of each color are the same in a bag, and use large bags.
Yeah.
So the same thing as what we're asking, but then all we're doing is getting a bag, counting all the colors, and then doing an ANOVA test on it to see if, because either they're all the same, right? Is that right? Or maybe I'm messing stuff up.
It's something like that. They're either all the same or one of them, at least one's different or something.
Yeah.
Which I'm pretty sure like at least one would be different, right? But
yeah, it seems like it. But that could be, I mean, our null hypothesis is that they're all the same. There's all equal proportions.
Right.
It's kind of fun we're using the word proportions when it's quantitative data. But, let's see here. That's not what I want. Yeah, there we go. Inference of several means. Okay, so if we do that, then I mean, how big does our sample need to be, though?
I don't know.
Like, do we need to get more than 3 bags total?
Gosh, I don't know. Let's see.
Probably not. I don't know, maybe.
It just says you will still want to randomize stores and randomly pick bags, so please keep those procedures. I would recommend that you purchase 6-ounce bags or larger rather than fun size. Smaller bags won't have enough of each color. Yeah, I mean, he didn't say like a specific amount of bags, so.
How big is a 6? Oh, a 6 ounce is just the normal.
Yeah, your typical bag.
Okay. So I guess we could probably each get 10 of those or so.
Yeah.
We'd have 30.
For what is this, ANOVA? Is there a minimum amount, or is it just, I can't remember if there is.
The requirements are that the data are normally distributed in each group, and the variance are equal for each group.
And is there like a test to see if it is normal or not? Like 30 or more, or just, I don't know.
Yeah, I mean, that's the whole central limit theorem, isn't it?
I don't know anymore.
If your sample size is large enough, that the sample means will be normally distributed.
But I mean, what's large enough for ANOVA though? Do we know that, or is it?
I don't know if it's necessarily different.
Okay. So 30 bags sounds fine.
Okay, how much is a 6-ounce bag of M&Ms? On Amazon, that's a 12-ounce bag. 6-pack of 12 ounces, $30.
Really?
42 ounce. No, I don't want that. Sam's Club. At Sam's Club, it's $24 for a 12 count.
So you're getting 12 6-ounce bags. Is that how it is?
Yeah. Technically, it says they're 5.3.
5.3.
But yeah, well. Huh. Well. Yeah, I mean, I'm kind of thinking we could probably just we could each get a large bag and count them and combine our numbers, because then the sample size, I mean, then we're counting, well, I don't know.
Yeah, I see what you're saying. So what size is a large bag? How many ounces is that?
Well, a large bag is 42, and that's $8.
Okay. Yeah, I'm fine with that if that works.
I don't know.
So I noticed we got 1 out of 2 points for state your null and alternative hypothesis correctly.
Uh-huh.
What did we miss on that? Do you know?
Oh, here we go. Says the null hypothesis is that would be that there is an equal distribution of red and blue M&Ms in each bag of fun size M&Ms.
Maybe it's the fact that we said fun size M&Ms?
Yeah, well, and we're looking at the distribution of red and blue.
Uh-huh.
So if we do it in an ANOVA test, then the null hypothesis is just that there's an equal distribution
Right.
of all of the colors. And
Okay.
the alternative is that at least one of them is different.
Okay, that sounds good.
Because then if we do, yeah. So I think we can try submitting that and see how that goes. Because then if we each just get like a 42-ounce bag and count all the colors, then we have those 3 distinct samples that would have a fairly large number in it.
Yeah. Yep. So I'm just trying to think it out. So we're not saying that in each bag. Wait. So okay, what would our null be? That there's an equal amount of each color of M&M. Is that right?
Yes.
Okay.
Well, yeah, our null is that there's an equal distribution, so the same number of each.
Okay.
Okay, so let's see. Yeah, so what population are we studying? Are we just trying to extrapolate this to all M&Ms that there are? Or, well, I guess we're extrapolating it to say that each 42-ounce bag has an equal distribution.
Yeah.
Oh, excuse me. Okay, so our research question is, is there an equal distribution of colors in peanut M&M? Let's see. What if we, well, no, we don't want to do that. Okay, equal distribution of colors in, so I know Jason wanted to do peanut M&Ms.
Okay.
Do we want to do peanut M&Ms? I guess these are peanut M&Ms.
Yeah, that's fine.
Okay. All right. So the population we are studying is 42-ounce bags of M&Ms. Okay. Our null hypothesis is that there are equal distribution of Okay, the alternative hypothesis is that at least one of the colors differs, right? I don't know. Do we want to do 42-ounce bags, or do we need to do smaller ones so we have smaller sample sizes?
That's fine with me. I mean, I don't know if 42 ounces is necessary, or if we could get away with doing a smaller sized bag. That might be simpler.
I'm thinking if we do a smaller size bag, we probably need to have more bags.
Okay.
Well, I'm thinking either way, we probably want to have more bags so that we're actually getting, you know, more distinct sample groups. That makes sense. More sample means.
Right. Right.
Just having a really big sample from a big bag,
Right.
but that costs more money. That's okay. I'm okay with that.
Yeah. I guess it just can't be too small because he kind of wants us to shy away from that.
Yeah. So as long as
Yeah, my phone is ringing, but it won't let me answer it for some reason. So okay, and it didn't show who's calling either, so that's kind of weird.
That is weird. What's up with that? Huh. Okay, so should we just say that we are doing? Well, there's so many different sizes.
Well, let's just do the 5.3 because I mean, he said 6 is fine, so.
Yeah. They actually have at Walmart. What's a typical size? Because that might be a weird size. 3.5. There's so many different sizes. I don't understand that. 6 ounce. That's not all I want. Huh. All right. How about
What's that?
because it looks like there's fun size and then the next size up is 12.6 unless we get that pack from Sam's Club.
Right.
I think the typical
I mean,
size.
Yeah, 12.6 is fine if you want to do that.
Yeah, and then we could just go buy however many you feel like you can buy, I guess.
Okay.
Want to do that. That'd work. Okay, so we'll say we're doing 12.6 ounce bags.
Okay.
Population is 12.6 ounce bags. All right, I think that would be good.
Yeah, that's good.
Hopefully that gives us enough since they're peanut M&Ms. They are bigger, but
yeah.
But I guess it's twice the size of what he said we have to have at least. So hopefully that's good.
Yeah. Some of these things he marked us down on, I don't really understand why. Like the overall organization and neatness of the document, I mean, we got a 0 on that. I don't know, like, how much neater can it get, really, you know? State which sampling method you used. Did we not do that or something? Because we got a 0 on that. I don't know.
Yeah. Well, we stated it, but it might be wrong because I think if you, yeah, I guess if you think of it as, we might be doing a, oh, now I'm forgetting. So there's a cluster sample and a, just because we're doing it based on Rexburg and then based on, so since we're getting them from different stores, then we're kind of grouping it. And so it might be stratified.
Okay.
Is what I'm thinking. Yeah, that's probably what he was thinking. So it's not quite simple random because it's stratified because we're not buying all the M&Ms from a particular store, but we're gonna go to a particular store and get some of the M&Ms from each of the stores that we're making part of this.
Okay.
Oh, my nose. All right. Cool. So the alternative hypothesis is that there is not an equal distribution. Or that. Yeah.
Got one more.
Hey, Jason's almost here.
Yeah. Can you hear us, Jason?
That took me 15 minutes to log into the stinking Hangouts app.
What happened?
Oh, maybe now you can hear me. Can you hear me now?
Yep.
Yeah.
I had mute on.
There we
It
go.
kept saying refresh, refresh. So I kept refreshing it,
And nothing.
Nah, it's good now.
Sweet.
How do you like our 40?
Pretty impressive. I mean, expected a little lower, so.
At least we got a redo? I mean, I guess
Yeah.
we got a redo, right?
Yeah. Yeah.
Alright. Well, I don't know what to do from there. So we just have to make our hypothesis easier? It's too complicated?
Yeah.
What are you guys thinking?
We're thinking of making it an ANOVA test. And he said not to do fun size packs, so we're going to do, what was it, 12.8 or something?
Yeah, a little bit bigger one.
Yeah.
Or 12.6.
Okay. And then I saw that he said that we need to do like different stores too, right? So they're not all.
Oh, the same store.
Yeah.
I guess I don't know why that would matter, but
Yeah.
it's not like they're like, well, Walmart only gets 5 blue ones in a bag. Target gets.
Right.
They don't. I don't know why that would matter, but that's fine.
Let's see. Acting the way I want it to. Trying to make it look prettier.
Nope, that's
Put
annoying.
little pictures on it. Just kidding.
Some pretty picture.
Well, I was just kidding. I don't think you have to, do you? Put pictures on it?
No.
Put a bow on it.
Put a bow on it.
Yeah. So are you guys excited for the exam coming up? I know you guys are.
Oh
Super
yeah.
excited, man. Super excited.
Is it this week or next week?
Next week.
Next week, yeah.
Next week, okay.
I'll probably get 100 on it, so I'm fine with it. It's no big deal.
Yeah, no big deal at all.
Whatever.
You know, it's funny because I'm finding that the most of the problems I'm missing are the ones where it's like they give a scenario and then what test, or yeah, they ask like what test you should use, and it's a bunch of the older tests, and it's like, oh my gosh, like this probably should be one of the easy questions, but I don't know, I keep missing those. I keep getting them all confused with each other, but oh well.
All right, so on number 4, I have which sampling method will your group use? So we're going to say that it's stratified sampling because each of us are going to go to a different store.
Uh-huh.
Is that right?
Yeah.
Okay. So basically we're going, let's see. Each of us going to just let's see. So what stores are we going to?
Could do.
How many do we need to get?
I'm trying to figure that out.
Well, one idea is we either just say we each get like 1 or 2 bags and see what he says. If he says, oh, you know, it should be more than that, then we do more, or I don't know. Do you guys think he would want us to do more than that, or what?
I mean, I don't know. I don't know what he's thinking about how many bags. I mean, I guess we were thinking we were going to do like a pack, right? So we were going to do like 15, 20 little packs of fun size, but he doesn't
Right.
want us to do those, right? So, I mean, does he want us to do like 1 or 2 bags? Do we need to do 5 bags? I mean,
I have no
I
idea.
don't know.
I think an idea we can do is say we're gonna get, you know, 2 bags, and then if he says, well, maybe you want to do more or less or whatever, then we go off of that. Or if he just, you know,
Yeah,
doesn't say anything, go with that.
I'm thinking we probably want to get like 5.
Yeah, 5 each.
Okay,
Probably good.
sounds good.
5.
But we still can't buy him yet, right? We still got to wait for him.
Yeah, I think so.
What stores are each of us going to go to? So we go to different stores.
I could go to Walgreens.
Walgreens?
Yeah.
Okay.
I'll go to Target, 5% back.
I'll go to Walmart. Okay.
Okay.
All right. Let's see.
We've got a new team member.
Yeah.
He's going to be our designated M&M eater.
There you go.
Can she do my part of the project too?
She probably would.
I know,
She'd
right?
probably love it.
Why?
That's for Halloween. We have this skeleton that we keep in a box,
Uh-huh.
and it's for Halloween, obviously, and it's like full size. And she wants to bring it down so she can sit on its lap,
Nice.
but it's in a box, like it's put away. And last 2
Yeah.
days she's been like wanting me to go up to the rafters and take it down, and that's not something that I want to do. So she's getting upset about it. Happens every couple hours, the last couple days.
All right, number 6 says, why do you think the sampling method described in the questions in 4 and 5 will give an accurate representation of your population? We think that what we're doing is going to work.
Because there's no bias, you know, with the store we're going to, or we're getting the same, you know.
Yeah, we're getting the same kind. We're
Same
getting.
kind.
Yeah, I agree. Stop. So when he was talking about the ratios between like a red and blue, did he not even want us to go that far?
Yeah, I don't think so. I mean, basically what we decided is we're just going to do an ANOVA test, and so we open up each of the bags, count the number in that bag, and then that's one of our data entries
Oh, nice. Okay.
for, and then, you know, the next row, the next row. So we'll just have each of the columns is a different color, and then what our null hypothesis is that there's an equal distribution of each color of M&Ms in a, oh, I need to change that. Whew.
In a bag.
12.6 ounce bag. And the alternative is that at least, or that one or more of the colors is unequally distributed within a 12.6
Oh
ounce
yeah,
bag.
that'll be good. Okay. So it could be different. It could be different colors, but in every bag, one color will not be equal. Okay.
Yep, at least one color.
Yeah, that's doable.
So yeah, that should work out.
That should work out.
We'll have the same type of M&Ms as well. All right. Dum 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 dum. Okay. How's this look? Let's see. So all of our names were on it, and then we needed to fix the research question stated correctly. Okay. Our research question is, are there an equal distribution of each color in 12.6 ounce bags of peanut M&Ms? Does that sound good?
Mm-hmm.
Yes.
Okay. What population are we studying? It's 12.6 ounce bags of M&Ms.
Yep.
And the null is that there's an equal. The alternative is that one or more of the colors is unequally distributed within, I should say, within 12 ounce bags. All right. Which sampling method will your group use? We are going to use a stratified sampling method due to each of us going to a different store to get the M&Ms so that we can use those as our sampling groups.
Good.
Does that make sense? Describe in specific detail how your group will collect data using the sampling method stated in question 4. Also state the sampling sizes you are planning to obtain per population. So I should probably add that to the end. It says each of us are going to purchase 5 12.6 ounce bags of peanut M&Ms from 3 different stores. We will go to Target, Walgreens, and Walmart. We will then count the number of each color in each bag and use these counts for the data in an ANOVA test. In total, we should have
15 bags.
15. Why do you think the sampling method described in the question, steps 4 and 5, will give an accurate representation? We are attempting to reduce bias by distributing the sources that we will get the M&Ms from, e.g. different stores. We are also going to make at least 15 bags which should help to make sure we have a reasonably large sample size. Each of the bags will have the same type of M&Ms as well, that is the peanut variety, so there shouldn't be any significant issues of M&M size differences.
Sweet.
Right. Okay.
And then we all sign it and say the project needs to be approved.
Yeah.
Bing.
You want to resubmit that, Jason?
Yep.
Do you remember how
Do
to
you
do
want to give me? Do I have access to this still?
it? Yeah, you should. I can send it again if you want. How do I?
Remember how we did it last time?
There you go. Did you find it, Jason?
Yeah, I clicked on it. It just opened up, and then I just go file and say or download it, right?
Yep. File, download as, and then submit that.
Yeah. Okay. Cool.
Cool.
Awesome.
Alrighty then. Cool. Should we take a quiz?
Yeah.
Let's do it. All right. All right. There we go. Oh, I should go open that one.
All right. There we go.
Categorical data.
And this is 19, right? Yeah.
No.
All right. You guys are all there?
Yeah.
Okay. I'll read
I'll read
number.
3.
Okay, go for it.
For questions 3 through 9, please use the following information. A public opinion poll surveyed a simple random sample of 1,000 voters. Respondents were classified by gender, female or male, and by voting preference, Republican, Democrat, or Independent. The results are presented here. And then there's the data. In this set of questions, we will explore the research question: do men's voting preferences differ significantly from women's voting preferences? Use a level of significance of A equals 0.05. Which set of hypotheses is appropriate for addressing the research question?
Okay.
I'm going to read all those, or are we good with that?
No, that's good. So
more female Democrats, more male Republicans, right? And then more males are Republican and Democrat than they are Independent.
well, I think we just need to say what the Nolan alternative should be. And I think with these ones, it's just a standard. I wrote down the row variable and column variable are independent, and then for the alternative, row variable and column variable are not independent. For me, I think that's the first one.
Gender and voting preferences are independent.
Yeah, and then
the A is gender and voting preferences are not independent.
I think that would be it. Yeah.
Yep.
Yep.
I concur with your analysis.
Okay, doctor.
Doctor.
All right.
Dr. Paul.
Number 4 says, what is the equation for computing the degrees of freedom? And I think it's number of rows minus 1, and then times number of columns minus 1.
That sounds about right. All right. This is an interesting way to... Correct choice for degrees of freedom for this problem.
So I guess we gotta
Choice of freedom.
Yeah,
plug all those
why
in.
it says choice, because it seems like there used to be a choice box thing.
Oh, yeah. Now we have to fill it in.
Yeah, now I have to fill it in. But I think it's 2. I threw it in the chi-square test thing.
Oh, okay.
Wouldn't it be 2 minus 1 times 2 minus 1, which is just 1?
Let's see here. So
Oh, because there's independent. Yeah.
number
I
of
was just
columns, you've got 3, so it's 1 times 2.
Yeah.
Okay. Yeah. There you go.
And it doesn't say to do decimals, so it's just 2. Okay.
I think so.
All right. Number 6. Are the requirements for conducting a x-squared test for independence met by this data set?
Chi-squared. Let's see here. Requirements. You must use simple random sampling to obtain a sample. Each expected count must be greater than or equal to 5. So if we look at our spreadsheet, each expected count is greater than or equal to 5. And yep,
Cool.
we'll assume that it's simple random sampling.
So which yes is it? Yes, there are 5 observed counts in at least one cell, or yes, there are at least 5 expected counts in each cell?
At least 5 expected counts.
Okay.
Cool.
So if one of those would have been less than 5, then it wouldn't have worked, right?
Yep.
Meaning if one, like if the 50 was, instead of 50, if it was 4 independent, it wouldn't have worked?
Yep.
Okay.
Understand.
Okay.
Number 7, what is the value of chi-squared test statistic for this problem? So the chi-squared test statistic, what do you guys get?
I'm filling that thing in real quick.
Oh, okay.
Let's see. Okay, I got 16.204.
204?
Yeah.
Oh, I got 16.20.
Oh, I just made mine to 3 decimal places, so whatever. Oh yeah, 2. Yeah.
Oh,
Yeah. It just wants 2 decimals, so that's good. 16.2.
16.20.
And then the next one goes 3. What do you know?
It says, what is the value of the p-value for this problem? I got all 0 because it's 0.0003, but around 3 decimals and it's all 0.
Yeah. 0.123. Okay.
Oh, excuse me.
All right. Which of the following statements best describes the outcome of this study?
I think it's going to be sufficient because it's less than 0.05. But
Right.
which one is it? So there is sufficient evidence to suggest that gender and voting preferences are not independent. There's.
I think that's the one.
Yeah, that's it.
The last one. Okay.
All right, so number 10 says, in this set of questions, we will review the reasons for seeking chiropractic care data. Please use the data.
To the data.
Man, the last one we have to open up something.
Fancy.
Yeah. Then it says, the research question for the study is, do people in Europe, Australia, and the United States seek chiropractic care for the same reasons? Use a significance level of 0.05. The hypothesis for the study are...
It's not quite laid out the way I want it, though.
Yeah.
I'm just going to type it in.
Okay.
Gotta type everything right.
Almost prevent 62 people.
Is this the same data that he had in the video?
Yeah. Well, the same kind of question. I don't know if the numbers are the same or not.
It's the same stuff. Same material. Well, I guess I could check my total and that'll tell me if I put it all in right. Yep. Just a good indicator if I did. Cool.
One sec.
Wish you could drop it in. Well, it already is, huh?
That'd be nice, huh?
Okay. All right. So what do we need to write down for this one? The conditions for conducting a chi-square test for independence are satisfied, and they're all greater than 5, right?
Yep, looks good to me.
Okay. So true. And then what's the degrees of freedom? Let's see. Did you guys get 8?
Yep. 2 times 4.
Sure. And what is the value of the x squared test statistic for this problem?
7.44.
Yeah.
There you go.
Yes.
Yep.
What is the p-value for this problem? 0.490.
Perfect. Okay. And that number is greater than 0.05, so
Yeah, 0.5.
not enough evidence.
There's insufficient evidence to suggest that motivation to visit a chiropractor
Is not independent of the location.
That's because the null is that. Yeah, there's insufficient evidence to suggest that the motivation to visit a chiropractor is not independent of the location.
I think that's it.
I think that's the one.
Yeah.
Okay.
All right. That's the last one, right?
Yep. That was a shorter one today.
Yay, 100%.
Yay, 100%. Sweet. Okay. So yeah, let's resubmit that thing and see what happens.
I will log into that real quick.
Now we can go think about, well, not now, but then we can go.
Yeah, we can start to think about thinking about getting the eminence.
Yes.
But until then, don't even think about it.
Don't think about it.
All right, cool.
I'm uploading it right now to it, so you can probably email him too and just double check with him. Sign the button.
All right, guys. I actually got to get going, but I will see you guys on Tuesday.
All right, see ya.
Okay, thanks. See ya.
Mm.